Hey all, this is Miss Morrison, Sarah, and my video cut off, so I'm picking back up. Okay, so we were on exponential functions. We already talked about these equations, and there's three different equations that you see, but there's three different cases we use them. Okay, so for this last equation, we use this last equation if it says continuous compounding. That means they don't apply interest once a week, once a month, once a year. They apply it continuously, very often. Okay, and then the second equation, it says compounding in periods per year. What? That's like saying, you might see the word biannually, or you might see, and that means twice a year, because bi means twice. You might just see annually or yearly, and that means once. And then the other one that's pretty big that you might see is quarterly. And quarterly is 4 times a year, because there's 4 quarters in a dollar. Okay, so if it gives you the word continuous, that's when you use this last equation. If it uses the word biannually, yearly, quarterly, or some other fancy word to describe the compounding, you use this middle equation. And then this first equation, you use if it says no compounding. And honestly, we're not going to use this first equation. This first equation means you just have the interest applied once, whereas this second equation, you get interest many times a year, like you earn interest twice a year for biannually or 4 times a year for quarterly. Okay, so if you see the word continuous, these fancy words, or just if you don't even see the word compounding, that's how you know what equations to use. Okay, it says, suppose that $15,000 is invested with 2.5% interest under the following compounding options. Determine the amount in the account at the end of the 7 years for each option. Okay, so with these formulas, let's talk about what all these letters mean. Capital A at the very beginning, that means how much money you've accumulated. Accumulated means you added up over a bunch of years. So the capital A means how much money you have at the end of the time that they tell you, okay? Capital P means principal with a L-E, not your pal. Okay, and principal is the money that you have at the start. So let's say I want to open up a bank account for my kid that was just born, so that when they go to college, they have a bunch of money that they can spend, and they feel safe. So that would be the principal. The money that I put into the account is what we start with. The money that we end with is the accumulated. Okay, then we have the little r, and that's the interest rate, which you guys probably could have figured out. Yeah, you probably already knew. But interest rates cannot be typed in the calculator. Like, we can't just say 15 and have that count as percent. We have to, and there's no fancy symbol for the percent on the calculator. So for interest rates, you have to move the decimal twice to the left. Yeah. So for us, well, we're not going to talk about that yet. And then the N is the compounding, or how many times they take the interest from you. So that's where if you have these fancy words, bi, yearly, quarterly, those kind of things. And then T is the time, and it's usually in years. All right. Okay. Let's figure out what we got here. It says, suppose that $15,000 is invested. That means you put the money into the account. So if I want to put some money into an account for my little baby that I got, so that 18 years from now they have a bunch of money to go to college with, that money that I put in when they're a baby is the investment or the principal. So 15,000 is the P. 2.5%, percent, rate, move the decimal left twice. Okay, so our R was 2.5%. But now we're going to take that decimale and we're going to move it once to the left, okay? And then another once to the left. And when we put that new decimal over here on the left, don't pay attention to the R equals. It makes you see that there's like a number missing. So we need to change this to 0.025. Okay, so my R is 0.025. And then it says blah, 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 blah. Determine the amount in the account at the end. At the end is the capital A. The amount in the account at the end is that capital A. And then 7 years, that's our T. Okay, let's see if we can figure this out. Compounded annually. That's one of those fancy words. Fancy. So we use this second formula, the one with the fraction in it. And if you're thinking, how the heck am I going to do that? You're not. You're going to put it in a calculator. Okay. So let's see here. Capital A is what we're supposed to be finding. And I forgot to put a question mark, so we don't even know that. So just leave it capital A. A equals capital P. That was that 15,000. Don't write the comma. Open parentheses. 1 plus. So the 1 plus. Then R, which is 0.025. So 0.025 over N. See, it says N, but N is the N compounding periods per year. Yeah, okay. So annually, if something happens annually, that just means it happens once a year. Yeah, like let's say your family comes to visit your house annually. That means that family comes to your house once a year. Okay, anyway. So N is 1. That's kind of weird because it's on the bottom, but who cares? And then up in the air, we have the N again, which is a 1. And then smashed up on that T, 7. Well, that looks like 17. So let's put a little multiply dot in there. Okay, now let's remember to get up in the air, we have to use that caret button. Okay, and then to get this cool fraction, we're going to press either alpha, hey, come on. Oh, there, alpha. Okay, then y equals, and then enter to get your little decimal boxes. Or you're going to press, you might be able to press alpha and then this button right next to it, X. Yeah. Or you might not even have those. Okay. So, I think I'm just going to, what did I say? I said alpha, y equals, enter. And if you don't have this option on the calculator in your hand, try downloading the app, I think it's called Calculate 84 or Calc 84, and it should have all the updated buttons for you. So if your calculator doesn't have these buttons, it's okay. It's just older, and you can use the app in class. Okay, let's see here. Let's type this in. 15,000 parentheses 1 plus alpha y equals enter 0.025 arrow down to get to the bottom of the box 1 Then when you're in the bottom of that fraction, you cannot put your close parentheses. You have to get out of that fraction. So press the right arrow button until that box is real big on the right, and then press parentheses. See how it's real big? Okay, good. Then press that arrow, and then 1 multiply 7. And anytime we're applying interest rate, that means we should have more money at the end. So since we started out with 15,000, we sure better end up with more than 15,000. If we don't, we wrong. Oh, look, we did it right. Okay. So our answer is this 17,830. But then let's look at this decimale part. We have point, can you see that? 286? See that? 0.286? Okay, well, we're rounding like money, honey. And money has 2 spots after the decimal. Alright? So either I'm going to keep this at 28 or bump it up to 29. And it depends on this 6. This 6 is 5 or more. So we're going to up the score. Yeah, so this 6 is 5 or more. So we're going to change that 28 to a 29. I don't know what just happened, but we're changing it to a 0.29. Okay. Okay, so this answer is, what is it? 17,830.29. We said bump it up to a 29. All right. Okay, let's look at what's underneath. Part B. It says compounded quarterly. That means same formula, because it has that fancy word quarterly, only our N is going to be different. This little Juan down here that was from annually is now going to be something else. Okay? Quarterly means 4. So I'm going to use this exact same formula with all the numbers. The only different number is going to be, I need that 1 on the bottom of my fraction and that 1 in the top of the air to become a quattro for quarterly. Okay, and then I'm going to show you something amazing. In pre-cal, when you type a bunch of hoopla and you need to retype it, but you're too lazy, press second. See how it says entry in blue? That means it pulls up everything you just entered into the calculator. So I press second, enter, and hot dog, it pulled up that last thing I wrote, so I just need to scroll over and get on top of that 1 and put a 4. Then get down somehow. Get down, get down. Okay. All right, we fixed our 4s. Now let's press enter. And remember, our answer sure better be bigger than 15,000. If it ain't, we wrong. Oh, we right. Okay, so this is, let's see, 17,858.964. And remember, 4 or less, let it rest. So I'm going to let this 96 rest at 96. Okay, and those numbers should be super similar, only the more times you compound, the more money you make, or the more interest you're going to have. So if the credit card company only asks for interest from you annually, that means they only apply interest once to your credit card bill. If they say they're going to apply interest to your credit card bill quarterly, that means 4 times. But usually it's continuously, like all the time. They don't give us a break at all. They don't care. All right, so anyway, let's go. So anyway, every time you compound more, you have more interest, either more money to pay or more money that you get in your pocket. So for part A, we only had interest applied once. Part B was 4, and that's why part B has a bigger answer than part A. And then part C is compounded continuously. That means like every second, every day, at every bill. So we use a different formula. It's this capital A equals capital P little e r t, And some of you are probably thinking, what the heck is E? It's special. Okay. First off, let's plug in everything that we know. We don't know the A. The P is the same P from before. The E is a button in your calculator. E is actually a symbol. Y'all remember this symbol pi? How if I press it in my calculator, I get out 3.14? Yeah, okay. That's pi. Okay. That helps us with circles, triangles, any kind of geometry, any kind of shapes. Okay, then we got this thing called E. It's named after this guy named Euler, and he is right here. Or, where is he? Here. So either we press some kind of button over here, or we press some kind of button over here, but not both. Okay, so to get this E, you see how it's blue? So I'm going to press the second, and then E to the X. And it's awesome because it pops that little box up in the air that we're going to need in a minute. If we try and use this other E over here, it looks like second E. Okay. That's the same E, but it just doesn't have that little box in the air, so you'd have to press an extra button. And if you're wondering what E represents, pi is 3.14, E is 2.718. It's a number that we use often in circles, geometry, area. Oh, okay, yeah. Anyway, so what you need to remember is this E is not some specialness. E is a button in your calculator. You press second and then LN. Woo! And then whatever is in the air, let's go ahead and write that down. I think we already knew it. R was 0.025. And then what was it? T? T was 7. But that looks like 257. Ooh. So we need to multiply those. And I don't want you to get it confused with that decimal dot, so I just put some parentheses. It's cool. We could have put a multiply dot. It's cool. Okay, so let's type 15,000. Here we go. Then we press second, LN, and then RT is 0.025, and either you can put a times asterisk, or you can just put parentheses 7, either one. And we sure better come out with more money than 15,000, and we did. We got 17,868.69. Then there's a 3. 3 is 4 or less, so we're going to let this rest. All right, and if you look, continuous should be the biggest amount of money every time. See, annually is like 830, quarterly 858, continuously 868. And keep going. These are kind of some bass-backwards equations. We're going to be using these formulas in the next section for exponentials and logarithms. These are the types of word problems that are in real life, that real-life mathematicians work on to either mathematicians or scientists to help the world out. So let's look at this. It says weapon-grade plutonium is composed, like in nuclear warheads or something, is composed of approximately 93% plutonium-239, or Pu-239. The half-life of Pu-239 is 24,000 years. So that means if we drop a bomb right now at year 1, 93 93% of the plutonium is just gonna go into the atmosphere and into the groundwater and into the roots and everything. Yeah. Whew. Okay. But then the time it takes for it to disappear by half, let's see, 93 divided by 2. Okay, so let's say year 46. 47. So 47 years later, wait, my bad, hold on. My bad. My bad. I was saying that, okay, if we drop a bomb and there's 93% plutonium, its half-life describes how many years it takes to just have half of that plutonium left. So, if I just have half of this plutonium left in the groundwater, in the air, the humans, everywhere around me, that's 47%. And this is saying that it takes 24,000 years. So if we drop a warhead somewhere, let's say in the Atlantic Ocean, okay, well, at year one, 93% of the plutonium from the warhead will be present. It will take 24,000 years for all that bad stuff, or half of that bad stuff from the warhead to disappear. 24,000 years. Okay, it says in a sample originally containing 0.5 kilograms, so this is like saying, okay, if your warhead had 0.5 kilograms of plutonium, then it says the amount left over after T years is given by the... Okay, so this 0.5 is what we start with. Okay, this 1/2 describes the half life. If this question were talking about the fourth life, we would have 1/4, and we would be describing how long it took for that plutonium to decrease, not by half, but by a fourth, or, yeah, okay. Anyway, so half-life means 1/2. This T is the time at the very top. And then the 24, what does that say, 1,000, is the time it takes to half itself. Yeah, okay. Okay. And if we look at this formula, or if we look at these problems, it says evaluate the function for the given values of t and interpret the meaning in context. Okay, if you look, there's t in the parentheses. Okay, so way back in the day, like if you had f of x equals 2x plus 1 and f of 3 equals question mark. Okay, let's say I had this. Back in the day in college algebra, you would take this 3 and put it where this x was. So 2 times 3 plus 1. And then f of 3 would be equal to whatever this hot mess was. 2 times 3 is 6 plus 1, 7. Hey-o! So the point of this was to take the number that they give you and plug it in the x. Or for us, they gave us a of t. Okay, so that means when they give us a of a number, if we would have had function notation with f, then we would have taken that number and put it where the x is, because that x is what's in the parentheses. Here we have a number. We're going to plug it into the t because the t is what's in the parentheses. Okay. So this number is the t. Okay. So, let's see what I get. Okay. And the capital A is the amount left after t years. Yeah. So capital A is the amount left after t years. So I'm plugging in 24,000 for the letter T to try and figure out how much plutonium is left after 24,000 years. Okay, let's try it. So I'm going to take my formula, and I'm going to say 0.5, parentheses, 1/2, and then we're going to take 24,000 divided by, what does that formula say? 24,000, yeah. And you're probably thinking, what, is this a trick? It is, just wait for it. Okay, so we get 0.5 times 1/2, and then this 24,000 divided by 24,000, that's just 1. What? Okay, and then let's multiply this. Okay, let's see here. We have 0.5 times 1/2. Oh, and it says we have 0.25. Okay, and let's try and figure out what this is. This 0.25 is not the time, because T is the time. The only other letter in this formula is the capital A, and capital A is the amount left over, so this is the amount left over of plutonium. And when we're measuring plutonium, we measure it in, I thought it just said it somewhere, kilograms. Kilograms, okay. So after 24,000 years, only 0.25 kilograms remained. And that makes sense, because let's look back at our picture up here. Remember in year 1, let's say we have 0.50 of plutonium. Okay? Its half-life is 24,000 years. So at 24,000 years, I should have half of this. So half of 0.50 is 0.25. Hey. Yeah, so this first one is automatically usually going to be the same as what they gave you in the word problem. So it says after 24,000 years, like what we discussed, only 0.25 remains. And it's asking for the kilograms, not the percentage. Okay, let's look at part B. Same-ish thing. Only T is 72,000. Okay, so let's plug in our goodies to this formula. We're going to have 0.5, parentheses, 1/2, 72,000, divided by 24,000. And that gets 0.5 times 1/2. And I think that's 3. Let's see. 24. Yes, it is. Okay, to the 3. Okay, and when you put this in your calculator, make sure you use the caret button for this tiny little 3. So we're going to press 0.5. And then if you want to do that alpha y equals enter thing, nope, that didn't work. Okay, let's try 0.5 parentheses alpha y equals enter. Okay, 1 and then 2, parentheses caret 3. Or you could have tried just with a simple division slash instead of that fancy y equals button. But either way, we should get 0.0625. Okay, let's write this down. Okay, so this means after 72,000 years, only 0.0625 kilograms remained. Yes! Okay, and then these next two problems are pretty much the same, only instead of talking about a mineral, or not a mineral, an element, and how much of that element is left after a certain amount of years. This one talks about population and how population grows after a certain amount of years. Okay, so let's check this out. It says an estimate of the population of Mexico was 111 million people with a projected growth rate of, okay, I don't know what this 111 is yet, but it's something. And then this 0.09, that thing, it's kind of weird because it says growth, but then it says rate. Yeah. So interest rate, growth rate, the half-life, we get to use the same format of formula where we have a big fat number at the front, or P, the principal, what we start with. Then what happens to it with the compounding. So this is a half-life. And then up in the air describes the time and the rate of decay or something like that. So here, 111 describes the population at the very beginning. 1.09, yep, that describes the rate of growth. Okay, so let's talk about this rate of growth, because I see 1 point, but then up in this words, I don't see one, the number 1. Okay, so our R is 0.0994%. That looks weird. No, that's not what it is. This is it. Okay, here we go. 0.994%. Okay, let's go ahead and move the decimal A twice to the left. Okay, and this makes 0.00994. Okay, but this is how much our population grows after 1 year. So these are all the extra little babies that we have after a year. If I want to know how much the population grows, I want to know the population that I started with, plus how many extra babies were born, or whatever. That's what I'm trying to figure out. So you can think of this point, this number, you can think of this as like, let's say it's the babies that were born in a year, or the deaths that occurred in a year. Either way, they averaged out to this. Okay. Well, I want to take, for this rate inside, I want to know the growth rate, as in it's different from just this baby's born. The growth rate takes into account the original people that were already there, plus the babies that were born. And the reason I'm using a 1 is it's kind of like saying 100%. Only I went ahead and moved the decimal twice to the left. Okay, so this 1 plus blah, blah, blah describes the people already there, plus the new people. So that 1 describes the people already there in Mexico when we started measuring. Then the 0.00994 describes the amount of new people in Mexico after 1 year. So our growth rate is actually 1.00994. And if this would have said decay rate, I would have subtracted it. Okay, so let's see here. That's where this R came from. You see that? So inside the parentheses, we have the rate. 111 is the people that we started with. And then what do you think this T is? Well, let's see. It says, at this rate, the population, P of T in millions, can be approximated by... And there should be a T in the air, right there, where T is the time in years since the first estimate. Okay, it says evaluate P of 4. Well, we know how to do this. Same way we did these last 2 problems. You plug in a 4 into this equation. So my equation is 111 parentheses 1.994 And then don't forget to use the caret to get up in the air. And that t is now 4. All right, let's put this in the calculator. And remember, we are talking about human beings. And when we measure human beings, we measure humans in whole numbers. We do not measure humans in decimals or parts of a fraction. We haven't done that since way back in the day, before civil rights. So we are going to get a decimal out of this. Ooh, 5.9. Okay, awkward. So this is a decimal. Does it tell us what to round to? Let's go ahead and round to the whole number. Okay, if I round this to a whole number, that means I just want either 115 or 116. Well, this is 4 or less, so I'm going to let it rest at 115. All right, let's figure out what the heck this 115 is. 115 is this P thing. This P thing is the population in millions. So we're going to write the word millions after it. It's like the, what's it called? Unit. So we have 15 million, people in, I don't know how to, what's the abbreviation for Mexico? Oh, don't make fun of me. Okay, I'm just going to say this. 15 million people in Mexico after 4 years. Okay, now let's try 75. So let's try 75 years from now. I'm guessing there's going to be a lot more people. So we're going to still use that same formula, but instead of 4 in the air, we're going to put 75. And then whatever number we get, remember, we don't count people in fractions. They are not pieces. People are whole numbers. My bad. Hold on. I forgot a 1. Okay, I think I did it. Let's see. Oh, yeah, there we go. So we get 233.07. Yeah. And this one is going to round down also. So we just have 233 million people in Mexico after, what is it, 75 years. Okay, let me tell you. So both of these were rounding down. Let's do an example where it's not rounding down. Let's say if you had 233.58. Okay, what did I say about people? We cannot measure people in decimals, so we have to have a whole number out of this. Also, if I say 234 people in 75 years, that's rounding up because 5 or more makes it go to 234. But think about it. Is there 234 million people? Nah, bro. There's only 233.58. Oh, gosh, how do we even say that? 233.58. Okay. All right, so this is the number we would use if we rounded up, like all math tells us to, round up. But hopefully you can see that there's a bunch of missing people. Like, that's not 234,000 or 234 million does not for sure cover all these people because there's people missing. Do you see it? Yeah, there's yeah. So we're not going to round up here. Instead, we're going to use 233 because for sure 233 million people happened after 75 years. For sure, 233 people. Not 234. If we wanted 234 million people, we'd have to go to like what? 70. We'd have to go another year, like 76 years or 77 or 78 or something. So the point is 234 is not the right answer. Okay. When you're dealing with people, always round down. So, on any of our problems for the rest of the semester, if we are talking about people, you always round down, because if you round up, there's a piece, there's a chunk of people that you're excluding, that you're leaving out. That's not, yeah, I think you get it. Okay, have a great day.